Sorry. Okay, so let us see this first question. Assume that the electric field E bar is equal to 30 x square I bar exists in the space. Then the potential difference VA minus V naught, where V naught is the potential at origin and VA is the potential at the distance x equal to 2 meter is. So in this case, we have to find out the potential at x equal to 2, and potential at origin is given to be V naught, and we want to find out the potential difference. So let us use the relationship between the potential difference and electric intensity in integral form, which is just like, देखो ये हमने already देखा था last time कि VA minus V naught is actually equal to integration of E bar into dx dr bar. जबकि यहाँ पे सिर्फ I bar का ही कोएफिशिएंट है, तो यहाँ पे टर्म भी सिर्फ I bar का ही आएगा, तो इसलिए फिर यहाँ पे 30x square I bar dot dx into I bar, so that we can just get this in the next step, VA minus V naught to be equal to, and minus sign should be there actually, but just you can solve it as it is. So 30x square dx, 30x square का 30 तो constant है, it can be taken out. x square का integration क्या बनेगा, x cube by 3, and if you just put the value of 2 here, x का value 2 डाल देंगे और उसके बाद 0 डाल देंगे, तो उससे हमको ये next step में हमको मिल जाएगा, देखो 2 का क्यूब बनता है 8 और 8 into 30 upon 3, तो 3 tens are 30, and hence 10 into 8 becomes 80, and hence we can just get that VA minus V naught is going to be minus 80 joule. That is the मैंने अभी बोला ना कि माइनस साइन यहाँ पे होना चाहिए करके, यहाँ पे आंसर में मतलब लेफ्ट राइट हैंड साइड में, तो इसलिए वो माइनस साइन की वजह से वो minus 80 जूल बन गया है actually. So we can just select this third option to be the correct one. Just go to the next one. A parallel plate capacitor is made of 2 circular plates separated by a distance of 5 millimeter with a dielectric constant 2.2 between them. When the electric field in the dielectric is 3 to 10 raised to 4 volt per meter, the charge density of positive plate will be very close to. Okay, so we want to find out the charge density of the positive plate. So here the circular plates से बना हुआ कैपेसिटर है जिसके दोनों प्लेट सर्कुलर है और उनके बीच में डिस्टेंस भी दिया हुआ है, डायरेक्ट्रिक कांस्टेंट भी दिया हुआ है और इलेक्ट्रिक फील्ड भी दिया हुआ है. ओके, तो चार्ज डेंसिटी ऑफ पॉजिटिव प्लेट we want here. Yes, so first of all we have to find out the capacity here. Yes, just here the formula is simply intensity, electric intensity in the interior of a dielectric is always given by charge density sigma upon epsilon naught into K, where sigma is to be found out and intensity is already given. So you can just solve it further and just take this 2.2 and 8.85 into 10 raised to minus 12 in that side, so that you can just get this sigma to be simply equal to 3 into 10 raised to 4 into 8.85 into 10 raised to minus 12, which happens to be 58.41 into 10 raised to minus 8 coulomb per meter square in this way, which is already there in the option number 1. Okay, बाकी जो चीजें दी है तो वो एक्चुअली वो कंफ्यूज करने के लिए दिया है, जैसा कि ये जो है 5 मिलीमीटर डिस्टेंस और सेपरेट सर्कुलर प्लेट्स ये दिया हुआ है, ये सब चीजें जो है वो जस्ट कंफ्यूज करने के लिए दिया है. You are not to use it in the numericals MCQs. Okay, let's move to the next question. 3 capacitances each of 3 microfarad are provided. These cannot be combined to provide the resultant capacitance of. Okay, 3 माइक्रोफैराड के 3 कैपेसिटर्स हमारे पास है. ओके, तो अगर हम सपोज इनमें से 2 को अगर पैरेलल में लगा देंगे या तीनों को अगर पैरेलल में लगा देंगे तो देखो 3 + 3 we can get it as 9 as the effective capacitance. Then if suppose these 3 capacitances are connected in series, then we can get it as 3 divided by 3, that means 1 microfarad capacitor as a result. Even if suppose the 2 capacitors are parallel like this, ये 2 कैपेसिटेंस यहाँ पे पैरेलल में है और उसके सीरीज में अगर एक अकेला कैपेसिटेंस है, तो ये 3 parallel to 3 just becomes 6 here, and a single capacitor of 3 microfarad in series with it will just give us the capacitance of 6 and 3. जब सीरीज में लगते हैं तो उनका इफेक्टिव कैपेसिटेंस क्या बनता है, 2 माइक्रोफैराड का बनता है. चेक करके देख सकते हो, ठीक है, बिकॉज 3 का डबल ही तो है ना वो 6, तो इसलिए बड़े वाले का 1/3 मतलब 2 ये माइक्रोफैराड, ये इसका कैपेसिटेंस इफेक्टिव कैपेसिटेंस बनेगा. और इवन अगर सपोज हम 2 कैपेसिटेंस सीरीज में लगाते हैं और उसके पैरेलल में अगर तीसरा लगाते हैं, तो अभी देखो ये 3 और 3 ये सीरीज में लग गए, तो इसकी वजह से यहाँ पे इनका जो कॉम्बिनेशन का कैपेसिटेंस है वो हमको मिलेगा 1.5. एंड 1.5 माइक्रोफैराड का जो कैपेसिटेंस है वो अगर हमने 3 माइक्रोफैराड कैपेसिटेंस के साथ सीरीज में लगा दिया, ये 3 माइक्रोफैराड का कैपेसिटेंस, तो इससे हमको 4.5 माइक्रोफैराड का कैपेसिटेंस मिल जाएगा आराम से. तो देखो ठीक से, ये 1 माइक्रोफैराड भी हमको मिल रहा है, 2 माइक्रोफैराड भी मिल रहा है, 4.5 माइक्रोफैराड भी मिल रहा है, लेकिन 6 माइक्रोफैराड कभी भी नहीं मिल सकता है इस केस में. इसीलिए ये दिस 6 माइक्रोफैराड मस्ट बी द आंसर. Okay, yes, that's what they have done here. When all the capacitance are in series, then the equivalent capacitance will be 1. If they are in parallel, then equivalent capacitance will be 9 actually. It should be 9. Okay, make it correct. यहाँ पे 3 के बदले 9 होना चाहिए. And when 2 are in series and 1 is parallel to them, then the effective capacitance becomes 4.5. And when 2 are in parallel and a single one, remaining one is in series, then the effective capacitance becomes 2 microfarad. Hence, fourth option is not covered here. Yes. The next one is a cone of base radius r and height h is located in uniform electric field E bar, which is parallel to its base. Okay, so electric field is going to be parallel to the base. Then what is the electric flux entering into the cone? Okay, so the electric flux which is entering into the cone will actually be the projection of electric intensity. This electric intensity multiplied by the area which is projection. मतलब ये जो ट्रायंगल का एरिया जो है वो हमको कंसिडर करना होगा. अगर ये इस इलेक्ट्रिक फील्ड को अगर हम सपोज इधर से जिस तरफ से इलेक्ट्रिक फील्ड जा रहा है उस तरफ से अगर हम उसको देखेंगे ना, तो हमको एक इस टाइप का ट्रायंगल दिखाई देगा. देखो, this type of a triangle can be observed here, and this area of this triangle will actually be the projection of the area of this cone. तो ये पूरे कोन का जो एरिया है उसका प्रोजेक्शन ये ट्रायंगल का ही एरिया होगा. इसलिए इसमें से जाने वाला जो इलेक्ट्रिक फ्लक्स है तो वो निकालने के लिए हमको क्या करना पड़ेगा, सिंपली we'll have to multiply the electric intensity by the electric field intensity must be multiplied by the area of this triangle. Now if you just find out the area of the triangle, then we can get this half into, so here पे base of the triangle is going to be 2r, right? 2r, and the height of the triangle is going to be h, so that this 2 gets cancelled here and we are left with e r h simply, which is there in option 2 here, which must be the correct one. Let us check. Yes. Okay, so E H into R will actually be the correct option. Let us move to the next topic, next question. Yes, a parallel plate capacitor is made up of 2 plates of length L, width W, and separated by the distance D. a dielectric slab of dielectric constant K that fits exactly between the plates is held near the edge of the plates. It is pulled into the capacitor by the force F, which is equal to minus of du by dx, where u is going to be the energy of the capacitor when the dielectric is inside the capacitor up to distance x. Okay, that means देखो यहाँ पे U is going to be the energy of capacitor when the dielectric is inside the capacitor up to the distance x in it. If the charge on the capacitor is Q, then the force on the dielectric when it is near the edge is charge on the capacitor Q dy, and the force on the dielectric, इस dielectric के ऊपर कितना force act होगा when it is near the edge. Okay. Okay. ठीक है, सिचुएशन समझो ठीक से. जो पूरा जो डायलेक्ट्रिक है वो पूरे इस कैपेसिटर के अंदर भरा हुआ है. और जस्ट we'll just take this question next time because it will require differential calculus also. Okay, so just try these questions. Just read the question. If the equivalent capacitance between the points P and Q of the combination of capacitors shown in the figure below is 30 microfarad, then what is the capacitance C here? तो C का capacitance हमको ढूंढ के निकालना है और effective capacitance यहाँ पे दिया हुआ है 30 microfarad दिया हुआ है. तो देखो, simply we have to use the formula for series and parallel combination. Since these 20, 20 and 20 are in parallel combination, all these three combined together will be equivalent to a capacitance of 60 microfarad here between these points. And this 60 microfarad capacitor is in series with the capacitor C, which is to be found out. And the effective capacitance is given to be 30 microfarad. So simply we can just say that here this ये जो C का जो वैल्यू हमको पता नहीं, but we know the effective capacitance here. So we can just say that the 1 upon effective capacitance 30 must be equal to 1 upon C, which is to be found out, plus 1 upon this combination. ये पूरे combination का जो capacitance है तो वो यहाँ पे आ जाएगा 60 here. And if we just take this 16 1 upon 60 in that side, then we can be able to get this 1 upon 30 minus 1 upon 60 going to be 1 upon C here, so that we can just get this multiplied by 2 here and get this 1 upon 60 only as the difference of these two, and hence we can just get this C is equal to 60 microfarad to be the capacitance of this combination, which is going to be there in the option number 1 here. Next one, how many 1 microfarad capacitors must be connected in parallel to store a charge of 1 coulomb with a potential of 110 volt across the capacitors? Okay, so matlab we want to store a charge of 1 coulomb and a potential of 110 volt, and we have the capacitance. All capacitance are of to be 1 microfarad each. Okay, तो देखो इसके बाद हमको समझना है कि when the capacitors are connected in series, then the charge is going to be the same, but potential difference increases. Okay, तो जबकि हमको यहाँ पे 110 वोल्ट पोटेंशियल डिफरेंस यहाँ पे स्टोर करना है, तो उसके लिए हमको सीरीज में उतने सब कैपेसिटर्स लगाने पड़ेंगे. और मतलब एक कैपेसिटेंस के अक्रॉस जितना भी पोटेंशियल है तो उसका तो ऐसे हमको नंबर ऑफ कैपेसिटेंस लगाने पड़ेंगे सीरीज में. और एक टोटल चार्ज जो हमारे पास है वो 1 कूलम है, तो 1 कूलम चार्ज हमको यहाँ पे यूज करना है, स्टोर करना है। तो सबसे पहले हमको ये सोचना होगा कि एक कैपेसिटर के ऊपर कितना चार्ज आ सकता है। सो वी कैन जस्ट से दैट इज C is the capacitor 1 microfarad, and potential difference we want is to be 110 volt. Okay, तो n कैपेसिटर्स अगर हम लगाते हैं, ऐसा अगर मान लिया, तो उस केस में you can just get that this Q is required to be 1, n is to be found out, C is given to be 1 microfarad, मतलब 10⁻⁻⁶ हो गया वो, और V जो है वो 110 है इधर। So if you just calculate n, then this 110 is to be put in the denominator, and this 10⁻⁶ will be there in this numerator here in this side. So it will become 10⁻⁶ and upon 110 here. That will be the value of n here. So n can be equal to, इसमें से एक जीरो अगर कैंसिल भी कर देंगे तो भी हमारे पास 10,000 अपॉन 11 बचा रहेगा। तो इस 11 से अगर इसको डिवाइड करते हैं तो हमको मिलेगा 11 9 जा 99, देन 10 बचा 0, और यहाँ पे फिर से 100 हो गया। So वापस 11 9 जा 99. So you can just approximately get this answer to be 909 in this way. See here, the C into V is going to be the charge on one capacitor actually, and since we want the charge of 1 coulomb to store here, so the total number of capacitors required can be just obtained by the total charge we want to store upon the total charge that one capacitor can store simply. तो ये भी हम कर सकते हैं आराम से। Let us move to the next question. The work done in placing a charge of 8 into 10⁻⁸ coulomb on the condenser of capacity 100 microfarad is, okay, तो चार्ज दिया हुआ है और कैपेसिटी भी दिया हुआ है और हमको वर्क डन निकालना है। सो दैट वर्क डन विल गेट स्टोर्ड इन द फॉर्म ऑफ पोटेंशियल एनर्जी ऑन दिस कैपेसिटर, एंड पोटेंशियल एनर्जी के लिए हमारे पास ऑलरेडी फॉर्मूला है जो कि Q²/2C, that we have to use it here. So work done will be equal to, either we can use this formula half of Q into V, but V is actually not given. So here we can just use this another formula for work done, which is going to be Q²/2C. याद है? तो अगर हम ये यूज करेंगे यहाँ पे, तो Q दिया हुआ है यहाँ पे चार्ज which is 8 into 10⁻⁸ coulomb. So we can just square it. So 8 का स्क्वायर हो गया 64, और 10⁻⁻18 का स्क्वायर हो गया 10⁻⁻36, and that is to be divided by 2 times of C, where C is going to be the capacitance, which is 100 microfarad, means it is going to be 10⁻⁻4 actually. So if we just work it out, then we can get this 32 into 10⁻⁻32. Yes, which is there in option. No, maybe there is some mistake. शायद ये 8 into 10⁻⁸ coulomb नहीं है। तो ठीक है, ये this will be the fourth one will be actually the correct answer. Okay, not this third one here. Go to the next one. charged oil drop of mass 2.5 into 10 raised to minus 7 kilogram is in the space between the two plates, each of area 2 into 10 raised to 2 centimeter square of parallel plate capacitor. When the upper plate has a charge of 5 into 10 raised to minus 7 coulomb and lower plate has an equal negative charge, then the oil remains stationary. Oil drop remains stationary. Okay. The charge of oil drop is, so see here, there is a simple situation of in which suppose this is the upper plate and this is suppose the inner lower plate, and suppose that there is a oil drop which is suspended in between these two plates like this here. So this oil drop will just experience two forces, one due to the gravity which is going to be there in the downward direction, we can just call it as mg. So this will be the force acting in the downward direction. Okay, and other force will acting due to the intensity of electric field here in the space between the two plates, that will be in the upward direction. And since the drop is just stationary, that means we can just equate this electric force with the gravitational force. That means m into g should be exactly equal to q into E here. Okay, so इसमें से क्या क्या दिया हुआ है चेक करो यहाँ पे. So ड्रॉप का मास तो दिया हुआ है, yes, then each area दिया हुआ है, चार्ज भी दिया हुआ है. ओके, जी तो ऑलरेडी हमको पता ही है, तो इसमें सिर्फ हमको ई निकालना पड़ेगा. ई मतलब इलेक्ट्रिक इंटेंसिटी जो होता है ड्यू टू द प्लेन शीट ऑफ चार्ज व्हिच हैपेंस टू बी एक्चुअली सिग्मा बाय एप्सिलॉन नॉट. करेक्ट है, ये फॉर्मूला हमारे पास है, जिसमें अभी सिग्मा मतलब क्या होता है, चार्ज अपॉन एरिया. सो वी कैन जस्ट गेट दिस एज क्यू अपॉन ए, that is multiplied with epsilon naught here. So we have to find it out. So what is the charge on the upper plate? It's given to be 5 into 10 raised to minus 7 coulomb, which is to be put here in the numerator. So here we can get here as 5 into 10 raised to minus 7 coulomb. And if a area of the each plate is given to be 200 centimeter square, but don't forget to convert it into meter square. So it will actually be 0.02 here, or we can say 2 into 10 raised to minus 2 meter square, because 2 into 10 raised to minus 2 multiplied by 10 raised to minus 4, which comes out to be 2 into 10 raised to minus 2 actually. And epsilon naught जो कि हमको ऑलरेडी पता है, उसका वैल्यू होता है 8.85 into 10 raised to minus 12. That's it. So if we just simplify this further, then we can get the electric intensity to be simply equal to 5 by 2 going to be 2.5 upon 8.85 as it is, and 10 के सारे पावर्स अगर करेक्ट कर दो तो ये हमको मिलेगा 10 raised to 12 minus 75 plus 2 मतलब 7 फिर से, तो 10 raised to 7 will be there in this numerator. Correct है? Yes. So this is the electric field. If we just put it here, then we can be able to get the charge on the oil drop, which is to be found out. So Q will actually be, so M is going to be 2.5 into 10 raised to minus 7. G is going to be 10 approximately. Q is to be found out, and E is already found out, that is 2.5 upon 8.85 into 10 raised to minus 12, 8.85, and that is to be multiplied with 10 raised to 7 simply. So this 2.5 will just get cancelled from here, and this 8.85 can be transferred to that side, and this 10 raised to 7 will also get transferred to that side, so that we get this 8.85 into 10 raised to minus 7 into 10 into 10 raised to minus 7 once again. That is going to be equal to Q. So finally Q happens to be equal to simply 8.85 into 10 raised to minus 14 plus 1, matlab minus 13, and that is in coulomb. So it will be 8.85 into 10 raised to minus 13 coulomb. which is already there in the option number 3 here. Okay. Yes. The capacitance of parallel plate capacitor with air as a medium is 3 microfarad. With the introduction of dielectric medium between the plates, the capacitance becomes 15 microfarad. Then what is the permittivity of the medium? See, formula for capacitance with air as a medium is going to be A epsilon naught up into upon D simply. But the capacitance with permittivity or with the dielectric is going to be A epsilon naught into K. इसको हम CD बोल देंगे. So upon epsilon naught as it is, sorry, upon D as it is. Okay, that means we can just understand that this CD is actually going to be K times of C here. And CD is given to be 15 microfarad. And C is already given to be 3 microfarad here. देखो ये वाला एयर फील्ड कैपेसिटर कैपेसिटी 3 माइक्रोफैराड दिया हुआ है और इसलिए फिर K का वैल्यू को क्या मिलेगा? K will be 15 upon 3. That means K will be 5. Once we get K, we can easily get the permittivity epsilon by using the formula epsilon naught into K, where epsilon naught is going to be 8.85 into 10 raised to minus 12, which has to be multiplied by 5, so that it will become 8 5s are almost 45 or 9 5s are 45 के आसपास आ जाएगा वो. So you can just select this 0.44 into 10 raised to minus 10 as the correct option. Okay. Yes. Same thing is obtained here. It's also very simple. A 500 microfarad capacitor is charged at a steady rate of 100 microcoulomb per second. Okay, एक कैपेसिटर को हम चार्ज कर रहे हैं, उसका रेट दिया हुआ है. How long will it take to raise the potential difference between the plates of capacitor to 10 volts? तो पोटेंशियल डिफरेंस 10 वोल्ट बनने के लिए कितना टाइम लगेगा वो हमको ढूंढना है. अब देखो रेट मल्टीप्लाइड बाय टाइम गिव्स अस द चार्ज, राइट. सो इसमें देखो एक सिंपल सी बात ये है कि रेट, जिस रेट से ये कैपेसिटर चार्ज हो रहा है उसको हम बोलेंगे dq by dt. सपोज if you just multiply this by time, then we can just get the total charge appearing on the capacitor, which has to be equal to the C into V here actually. So this time has to be found out here. So rate is given already, which is 100 microcoulomb per second, okay, into T, that is to be equal to the total charge, which has to be equal to C into V. So C is going to be 500 microfarad. So micro cancel हो जाएगा और potential difference is 10. We want it here. So if we just work this out, T happens to be ये 0 cancel हो गया, 5 into 10 becomes 50 here. So we can just get these 50 seconds to be the final answer in this way. Yes, the same thing we have done here. Okay, so let us finish this lecture here. Yes, thank you all of you.